Okay, part 3 of 1.6. Let me continue the lesson. This one is decompose a composite function. Find the two functions f and g such that h of x is f of g of x. And you got h of x as the following. Okay, what am I talking about here? So it's like going backward. So previously, when you did with the composite function, I gave you two functions, you are compositing to one function. What this is, we have a composite function, you are decomposing to two different functions, okay? So here is h of x, they want that to be f of g of x. I don't like this notation, I like f of g of x. I am intentionally using color code here for this one. So g of x is inside. So here's what you can do. H of x equal to 1 over x plus 2 squared. So let me show you, excuse me, let me show you the decomposition here. So you're choosing g of x. So h of x is the f of g of x. You are taking that into two different functions. So one thing you can do, you choose g of x as you like. But restriction says don't take anything as x. Because easy ways, I can say g of x is x and h of x is as it is. They are saying don't do that. So you can consider that as the following. I can consider that as this. This is exactly the same as that. But which one did I consider as a g of x? This whole denominator. Okay, then you might say, what are you talking about? Here. So g of x in this case is this whole all red thing, x plus 2 squared is a g of x. And f of x is this structure, 1 over this, which is 1 over that whole thing, which you can apply that as x. One over something, right? 1 over something. That's something, you can write that as x. And so when you composite this and this as f of g, you're plugging that into here, you end up with this. So that is one answer. But I'm just saying you could go decompose in different way. I can look at that function as following. 1 over, I can look at that as like this. Then you're decomposing as the following. So g of x becomes x plus 2. Then what is f of x? Well, f of x is 1 over something square, something square. What is that something? X. So this is also a correct answer of decomposition. So you have two options here. Okay. What they did the first one. It's okay. Either way is the correct answer. Okay, they are asking to decompose this. So, again, h of x equal to f of g of x, which is the same as f of g of x. What is h of x? H of x equal to 3x squared minus 12x plus 12. So right now, as it is, you cannot decompose. So you have to do some factoring. So if you look at it, 3, 3, 3 goes everywhere. So I can do factoring as a 3 for common factor, x squared minus 4x plus 4. Okay. Right then, I can decompose right here because I can consider that as x squared minus 4x plus 4. I can look at that as g of x. Okay, so right here I can decompose. I can do g of x as x squared minus 4x plus 4. I can do f of x as 3 times something, 3 times something. So that's one answer. You can do decompose. You're done. For textbook, they did a little further. They did a little fancier. So they continued it here. They factor that out. 1 times 1 makes 1. 2 times 2 makes a 4. But I need a minus. So if you do minus 2 times minus 2 makes a 4. Multiply, minus 2. Multiply, minus 2. Add them, you get minus 4. So I found a combination. So you can just write x here, parenthesis, parenthesis. This is a factor, another factor. So I did a factoring here. X minus 2 squared. So if you do all this work, you can do it differently here. You can consider that composite function as the following. You can look at that as like this. Then you can decompose a different way here. So you can consider g of x as x minus 2 and f of x as 3 times something square. Something square. That something is x. So when you composite, you plug it in g of x here, you end up with this. So that's another way to decompose. I mean, definitely, this is a lot easier. You don't have to do any factoring, simple enough. But they did this way. Okay, it doesn't matter which way. As long as you decompose it correctly, both works. Okay, pause the video, please. Then try this. Okay, so how did they do that here? H of x equal to square root of x minus 1 over 3. Okay, so they looked at that as like this. Square root of x minus 1 over 3. That's how they consider. So g of x, they took that as square root of x minus 1. F of x, they took something over 3. Something over 3, this is how they did it. Is that only way to decompose? No, it's not. You can do x minus 1 inside the g of x, and f of x would end up with the square root of x over 3. You could decompose that way too, okay? Okay, so please work on Alex homework after you've gone through 1.7.